Thank you, Ohad, and thank you, Ignacio. So just a brief introduction. My name is Eyal Gerber. I'm from Israel, and I have a small company called Novodes. We provide services in embedded software development and testing and setting up automation infrastructure using various tools, such tools that are also distributed by Analyses and Ohad, such as Kata for unit testing or Axivion, in this case, for static analysis. And right now, I want to show you a demonstration of how Axivion works. And I'll show you an active setup of how it looks like. So just one moment. I'll share my screen. Okay. Do you see my screen at the moment?
Yes, we see.
Okay, great. So this is how I wanted to jump in and just show you, first of all, how a dashboard of Axivion looks like. It's a browser-based dashboard in which you can see all of your results of the analysis and also timeline of the runs of analyses that you've done, see whether the situation has deteriorated, has improved, etc. So in this case, for example, you can see that I started out with 60,000 errors, and later on reduced it to about 20,000. So this is because after some analysis, I saw that many of the files included in my analysis were third-party, not related to the code that I wrote. So after I removed them and ignored them, I was able to get to 20,000. And now, just one second. Sorry about that. Anyway, so getting back to the presentation, what I want to show you is before we dive into the different types of errors that we have here, I want to show you also just a brief how to set up a new project. So when we want to set up a new project, let me go here, Axivion, sorry. And we go to project configuration. You have this new project wizard that enables you to set up a project very quickly. It's very intuitive. And I'm going to show you an example of how I've done all this for a real project that is based on UVision Kale, which is a very popular platform, but it also supports, Axivion supports many other IDEs such as IAR and others as well. So in this case, I'm going to use a managed uploading single machine. This is how you configure the server. So the way that it works, as Ignacio showed, is that you have all the results are stored on a server, and from there they're uploaded to the dashboard and displayed to all of you. So you need to decide how you want the architecture of this server to work. Do you want everybody to be able to run analysis on their computer, and then the results are sent to the dashboard, to the server somewhere else? Or is the server located on the same computer? So in my case, I'm not running a whole network here of computers, so it's very simple setup. It's a server on the same machine on which I'm also running the analysis. And so I'm just going to click here next. I'm going to choose the folder where my project is located. So just going to click here. Click next. I'm gonna choose a folder here that the project name, and I'm gonna choose the folder inside the project where we're gonna have all the Axivion files. Gonna click next. Here you can see all the various build systems that you can choose. In this case, I'm gonna choose Kale UVision because this is what my project is using at the moment. Next, I'm gonna choose the actual UVision project. I'm going to go into here. Great, and then I'm going to choose the target. So I have the project open. I have here various targets. I'm going to choose the application target. Just going to copy the whole name, just like this. The build product, what is it? Is it a binary file? So in this case, it's embedded software. It's a binary file that's uploaded to the target. So I'm just going to go in here and choose the location where the binary file is located inside the object app. And there we go. This is the bin file. Open. Next. And as you can see, it has identified also that the build system automatically, KL, C++ compiler toolchain. Next, I'm going to choose this type of compiler specifically. Next, here I need to copy paste the command line for the compilers. And this can take, again, from within UVision Kale in this case. So it's going to go here, and I can copy this entire part, paste it, one for the C. Oh, go here. This is the C, and this second line is for the C++. Just need to change here, C++ 14 in this case, and click next. And nothing else to add here in the advanced toolchain settings. And it automatically detected the compiler setup succeeded. Again, next, it says which kind of version control you're using, detected automatically. So there's a lot of automation, helps detect things. Okay, next. And I'm going to use the Axivion dashboard next, and which kind of the path or URL for the dashboard, how it's going to be localhost 9090 Axivion. That's fine. Now I'm going to stop here. There's just a few more steps, but I'm going to stop because I already did all this, and I don't want to have some kind of duplication on my system. So I just want to demonstrate the simplicity of setting up this dashboard, setting up the project. It was very intuitive for me, and this is what I wanted to demonstrate, just to show how simple this is. I've come across no difficulties, and it worked straight out of the box. And so I'm sure it is this case in most cases. And in any case, if you have some kind of difficulty, we can always try and help you out. So I'm going to stop here. I'm going to close this. And trust me that I've completed this because I have here the setup already running. We see the same URL as I've showed you earlier, localhost 9090 Axivion. Now, in order to, once you've done this, how do I get these results? How do I analyze the project? So once you've completed the wizard that I've showed you previously, I'm going to open the this viewer here. So this is the project, and this is the Axivion 2 folder that it has created for me while I was doing the wizard. I don't need it because I already have this original one, Axivion. Inside, it had created a start analysis.bat file. So if I open it, it has just a few settings. Actually, I will not open it right now to all of you because it has some sensitive information, like some passwords and stuff like that. But essentially, it contains all the information you need to start and run the analysis. So you simply run this from the command line or double click it, and it runs the analysis on your entire project, and it automatically gets all the build steps from your project file that I've provided earlier of the project from Kale UVision, and it runs everything through Axivion. And I won't do it now simply because it will take about 5 minutes to complete, and I don't want to waste your time waiting. So trust me that I've run this several times, and that's how eventually when it completes, you get this analysis. Essentially, the view is more correctly like this. This is how it opens up. and you can see various projects if you have others. In this case, I only have this one, and so I just click on this, and this is the view that you get. And I'll start, one of the most interesting parts here is actually the architecture violations. But before I dive into that, I need to show you how you set up architecture rules. But before we go there, which is, takes a few more steps, what is more intuitive to receive is all the rest. So without setting any architecture rules, you get all the other violations immediately. So this is very intuitive to get. You have here, for example, clones in my code. So I can click on this and see a list of all the clones that I have in my code. And I can see for every single part of code, who is the owner in my organization, who did this commit that is associated with this clone, and which file, right? And I can click on it. So let's say this one right here. And I actually see over here on the right, the problem with the clone and the description. And I see the exact location, but I can also scroll down and see that it tells me, hey, you have this code that is almost identical in two different locations. Let me see here. Yes, as you can see, it's the same file, but in different locations. So one here is line 63, it's the beginning of the file, and then you have the same code exactly at line 531. So it's kind of weird. Maybe I should investigate, is this a problem or not? It's up to me. But this gives you some visibility as to the what is this clone that it's discussing. Let me go back for a moment. See another example. Let's see here in EEPROM. It's also the same file. I'm looking for something that shows you. Hold on, maybe this one, base led. Yeah. Okay, this is another cool example. Here I have two different files. Okay, one here is called base encoder, and the other one is called base led. And you can see here that there's almost an exact copy of this function, but it's not exact, because you can see that the name of the class is different, the name of the variable is different, but the Axivion can detect that the structure of the function is completely identical. It's just the name of the variables was different, the name of the class is different, but everything else is a copy. So it's a way of telling you, hey, you have this duplicate. Maybe you can have some kind of single function that takes care of both this, in this case of the LEDs, in this case of an encoder, instead of having a duplicate and just changing the variable names. So this is another thing to consider whether you want to improve. So that's an example of code duplications that it finds. You have here cycles within your code. What are cycles? So it detects some kind of cycle going around between different modules. So if I again click here, it shows me visibility on the right here. Exactly what is the cycle? It tells me, in this case, it shows me that in this file, rangbuffer.h, I have this call to assert, and it shows me where the assert is located. And it can show me exactly within this whole location, where what this call is, this this red arrow from function right, as you can see here, right, to software assert failed, which is this one, to over here. So and then this is part of the cycle, because as you can see, it goes down the blue arrow down to right and back again. So this should be examined. Is this a problem? I have this kind of cycle in my code. In this specific case, we know it's fine. But again, typically you don't want these kind of things. So it's worth examining, is this by design or is it a mistake? Okay, so that's an example of some kind of cycle. And you have also dead code. So these are dead entities parts of code that are not accessed. So also, let's look at some examples here that I have. It says here that, let's see, the rule that dead routines and macros. This code probably is never accessed, never being called. ACI gap pass key response. This is never accessed, this is never called, so it's dead code. So we should examine, do we want to remove this, etc. So you have here many examples, but this is what it's what it looks like. You have metric violations. Let's see. Oh, okay. So this has to do with cyclomatic complexity. So this means, this is the description for all these problems. Cyclomatic complexity means that functions are basically too complex, too big. So indeed, let's say, let's open up an example of, okay, let's open this one. Okay, so we have this function in log engine, WS starts, it means warm start. So this warm start function is very big. Yeah, it's huge, very huge. As you can see, very complex. So it fails this cyclomatic complexity test, and it's telling me, hey, you should simplify this function. This is a violation of your rules. So it's indeed correct. This is something that we should improve on. And then there's style violations. Here you have the most errors, over 19,241 errors. And I can go into one of them and just see an example. Let's go in here. And this is directly from, tells you the error. It comes from Mistra C++ 2023 6.0.3 and gives me the entire specifications of this error, an example, what is wrong and how it should be written, and gives me the exact location of the problem. I won't dive into the exact issue, but this is how it displays the problem and highlights the specific line with the issue. And within these errors, which is typically when you do static analysis in with highly sensitive industries that require compliance, you care a lot about the severity of the error. So when you want to adhere to a certain standard, you want to verify, wait a minute, what is the severity? So here you have on the right a column for severity. This is required, this is advisory. You can filter and choose between them which type of what you want to look for, and simplify your view, and look only at those that are typically severe. Let's look at this one that is required. So this something that has to do with I think the way that we write the define of advertising H here at the top. Yeah, the appropriate form is not correct. Okay, so it's something that we need to improve on later on. So all these things, by the way, the type of standard that you choose, I didn't show you it in the wizard, but in the wizard, when you continue in the final steps, you choose there the types of standard that you want to adhere to, and you can always later configure it later on in this tool here. Sorry, not this one. This one called Axivion Project Configurator. So you open the project here and you can configure various aspects of the project. One of them is under style checks. You can see I can choose the various standards. So I want to analyze Mr. C 2023, 2019, 2012. You can choose here AutoSAR, C++, 1903, whatever. I can go through a bunch of standards and choose for my convenience what I know I need to comply with and modify it as I go. So it's very convenient to define everything here. You can also, as you go, if you see that files that you don't want to analyze, you can go here under global exclude, and you just add here all the files or folders that you want to exclude from your analysis. In my case, for example, unit testing files or third-party software, and stuff like that. So I gave you a view of all these types of metrics, and the last one that you want to look at is the architecture violations. So before I go into this, I want to show you something really cool, and that is how to define the architecture. So you have another tool of Axivion called Gravis, and so you open. Let me go back here for a second. Over here, you have an RFG. So after you run the analysis, you have this RFG to download. You download this file, and when you open it, it opens. It opens in this view of Gravis, where it shows you all these various layers. It might not mean a lot to you right now, and also doesn't mean a lot even if you open it. So let's say, for example, declaration facts. It looks like this. These are basically declaration facts. Essentially, is all the connections between every single file and every single aspect. So this doesn't give you much, right? But you can use this information to generate a few more layers called architecture and mapping. And based on this, you can run an analysis and define for Axivion what is your architectural rule. I won't go into the fine tunes of exactly how I build and create these, because that's maybe a more deep dive session. So I just want to show you how it looks like. So after I created a mapping, is essentially I defined, you know what, here are my folders on the left of my project, main folders. And these are the layers that I choose to define for my project. I'm going to have an application layer, drivers layer, HAL plus CPU hardware initialization layer, middleware, RTOS, and I need to associate the various files in my project with the various layers, what I want it to be. So let's say this is what I define as the ideal. And based on these rules, Axivion will later analyze my project. So in this case, I associated, for example, third middlewares with middleware, obviously, and generated sorts with middleware and middleware with middleware. And we have, for example, drivers is with drivers. You see here on the name and mapped to column, right? And you have RTOS with RTOS. And within the project itself, project folder, I have two other folders. So one of them is application, which is associated with the application. And I have this folder CPU hardware in it, which is associated with the CPU hardware initialization layer. After I define this, I also have this view, which is the layered view, which essentially my way of defining, okay, so I defined previously the what are the files that are associated with each layer. And in this view, I'm defining the relationship between the layers. So who is allowed to call who or reference who, and who is not. So essentially the lines defined in this case, I have a line from application going to drivers. So this says that anything within application can reference anything within drivers. But I don't have a line going in the other direction. That means it's against the rules to have something in drivers referencing something in application. So this is how we chose in our project to define the layers and the rules between them. And I can later run an analysis that has to do with the architecture mapping, and to generate an analysis within this view to show me visually the violations within the architecture. So I already ran this, and I have therefore this architecture check 2. I can just organize it for a moment to be similar like before. And you can see a very cool view showing that I have violations in red, and anything that is in green is according to the rules. So I have here various violations. And if I want to see them visually, I can expand them here. So like in this case, let's look at middleware, double click. Let's open, it has 3 folders, if you remember previously from the mapping. So I can see that there are problems here in third middlewares and in middleware. So let's open middleware in this case. Double click it here, and I see that I have both in source and include. Let's open source, and I see the various files, and I see a lot of problems coming from common cpp.cpp. Okay, so if I double click it again, let's go down here, I see the actual functions in this file, and I see all the problems come from raise hardware error. Okay, so let's double click this again. All right, let's click one of the lines here, and I get the actual problem. And I can, well, maybe this view doesn't give you much, but if I double click it one more time, it takes me to the actual file. And I see here that there is a referencing to internal data flags hardware error. And this enum is probably located in a different location. So if I go back, let me see here. Yeah, so it's telling me that, like I said, the enumerator use is from a different location. In this view, I don't see it so much. Where is this actually originating from? Let me close this for a moment. I have another example here. Let me try. Yeah, so in this case, I do see, again, another, for the same function, because there are various problems in this function. I have referencing this SD hardware error type. So this type is from a different location. So as you can see, this is a type problem, and the type is located in parameters GH. Parameters GH is located, I know, in the application layer, and as we saw, the lines coming from the application layer. So this is a violation where I'm referencing the application layer in the middleware. So that is the violation. Now, as you can see, I saw it here visually. I can also see the there's a way to see the entire list of let's see, visualization. There's a way to see, sorry, all the violations of the architecture, both here in a list. I won't do that right now. I want to show it to you in Axivion dashboard. So after I've defined this, when I run the analysis in Axivion, we go back there, you will get this line as well, showing all the violations. So if I click it here, I get all the violations, okay, and all the directions, and you can see here the sources. One is from drivers to application. One is from drivers to RTOS. Scroll down here. One is from HAL CPU hardware initialization to drivers. And you see all the various violations, and I can go into each and every one of them. So let's go from drivers to application in this case. Okay, it's telling me that in drivers, under this file of power management, I'm referencing this class object. And this class object is telling me, hey, this is defined in the sysconfig CPP, which is an application file. So you're referencing an application file, an application object from your drivers, which is the violation, and it's showing me this exact violation over here. Over here on the right, and it's explaining it again. So you have this visibility as to all the problems that you have. I've gone through all the various types of issues, and you have this timeline. You have also, by the way, for every single type of issue, you have the trend. So for example, for architecture violations, I had at first I didn't define any architecture, so I had no violations. But then once I defined it and ran it again, I had an increase of 201. In some cases, it had decrease. Why? Because I removed some files that I didn't want to analyze. So I had decreased, and maybe my code changed a little bit, so I had increased. So this is why you have this gain and reduction as you progress in your development. And it's very efficient to therefore see for each type of issue what you gained and what you managed to resolve as time progresses. So that was a very long monologue of mine, trying to depict and show to you how Axivion looks like and works. I'll stop talking for now.
Yeah, there is one additional issue that you can compare between two versions of the analysis between dates. Do you know how to do it?
Well, you have essentially, let's say over here, I think under, let me see, issue table.
Yeah, you see the 2 points, the scroll.
Yeah.
Yeah. So this
So
is
this way
you can compare
progress,
between
right.
two versions of the code from different dates and see how you progress with fixing the issues.
Correct, right. So you can look at here, you can drag this here, and then you see from here to here exactly what has changed, what is removed, what has been added. Correct. It's a great thing that you mentioned that to me. Thank you. Yeah, definitely. And you can see a summary on the side. So exactly how many was removed, how many was added. So here you see I removed 40,000 because I removed a bunch of files that were third party. So you say, okay, no, I don't want to compare that. I want to compare actual development progress. So let's move this over here. And now I can see, okay, so this is development progress. You can see that I added 42 problems and I removed 76. And yeah, definitely something that you can use to see in the dashboard.
Okay.
Maybe you want to give some time for others to ask some questions in the chat or something like that, if anybody has any.
Okay, the session is recorded, so anyway we can share this recording with everyone.
Mm-hmm.
So thanks a lot, Eyal, for the demonstration, and thanks a lot for participates.
Yes, absolutely. Thank you.
Thanks. Bye-bye.
Bye-bye.